11th program. So this is actually sorting program. As you all know how to sort a number. If I give 2, 3, 4, 5 and 1, you'll be knowing how to sort in an order, in an ascending order or an descending order. So this is the program about sorting numbers with the help of sorting techniques. So this program basically states, write a program to arrange a series of 32-bit numbers in ascending or descending order. That is, in increasing order or decreasing order. It basically depends on the user if you want to do ascending or descending. In this syllabus, we will be doing ascending order. What happens in ascending order? Basically, it is actually the increasing format of a number. So for an example, 1, 2, 3, 4 and 5 is an ascending order statement. So how does this program works? We'll take an example and check. So how does sorting works? If suppose this is an example I have given, basically sorting only works when you have unordered collections, which basically makes an ordered collection. If you are giving unordered collection, which is actually not sorted, then only sorting can be done. So I have given an unordered data here. So with the help of sorting, you can check the data is ordered in ascending order. That is from the smallest number to the biggest number. It has been sorted here. So this is the basic logic of sorting. Then we'll take an animated example. This is an example which I have taken here. Basically, I am giving unordered data. Now I have to set this data into ordered format. So how should the data come? 6 should be in the first block, 98 should be in the final block, because this is the minimum value and this is the maximum value. So as I am doing it in ascending order, the maximum value 98 should be stored in the final block, and the initial value, initial data, that is 6, should be stored in the initial block. So let's see how the sorting happens. First, it will compare these two numbers, 98 and 23. Is 98 greater than 23? Yes. So these two numbers should be sorted. That is, I can swap these two numbers because 98 is higher. So once I do swapping, you can check the lower number has come here, 23, and the final number has come here, 98. That is the largest number. Then I will check the next two numbers, 98 and 45. Which is greater? 98 is greater, so I should swap these two numbers. That is 45 is swapped. Then again I will compare these two, that is 98 and 14, which should be in first, 14 should be in first, that is 98 should be swapped to here. I am swapping. Then I will compare the next number, 98 and 6, which is greater. 98 is greater, so I should swap 98 and take the number 6 to the initial block. I should swap, and then 98 should be swapped here. So again I will compare 98 and 67 with, as it is smaller, I should swap again. Similarly, with respect to the next number 33, 98 is greater, so I should swap 98, and finally I should check 98 to be 42. This 42 is lower than 98. 98 should be swapped with 42. That is this. So I can tell the first pass is done here. The first pass is done because I need to swap. I need to order all the numbers in ascending order. You can see the final, in every pass, you will get each block has already sorted. Now you can see the last block is sorted. The highest number is in its place. This is the highest number, that is the end number, is in its original place. Now you can see there is no next number, so I will end the first pass. Then I will begin with the second pass from the beginning. You can see the blue colored number is already sorted. Next, in the second pass, I will compare similarly the first two numbers. You can see if 23 is greater than 42, no. So I'm not doing swapping here because it is already in the condition, because 23 is lower than 45. Then I will check for the next numbers. I should swap here, so this numbers will be swapped. That is 45 should be shifted. Then it is shifted. Then I will compare with the next number, 45 and 6. This number 6 is lower, so I should swap 45 as well as 6. Now it is swapped. I'll compare the next number, 45 and 67, which should be should it be swapped? No, right? Because it is already in the correct position. No swapping. Then I will compare next to this should be swapped because 67 is greater than 33. Now I will swap these two, that is 33 and 67. I will check for the next numbers, 67 and 42. 67 is greater, so 67 should be swapped here. So I will swap 67. Finally, I can't swap this because it is already there. 67 is lesser than 98, right? So it is in its correct position. So this basically tells finishing of second pass. So I have got last two numbers of the sorted array. Then similarly, I will start up with the third pass. You can see how many numbers are there? 3, 6, 7, 8. There are 8 numbers. What are the number of passes? The number of passes are 7. That is 8 minus 1 will be 7. 7 number of passes should be done. Similarly, I will start swapping here. Then I will get the last third number as well. That is 45. I got this. Again, there is no further swapping, so the third pass is done. In the fourth pass, it will again compare and it will give the another number of final array. You can see I got last 4 numbers. Similarly, I'll get the next numbers as well. You can see as there are no swapping, the fifth pass also ends, and finally I'll get the data. That is, with respect to this, you can see here all the data is being swapped. You can see it is in ascending order, right? 6, 14, 23, 33, 42, 45, 67 as well as 98. It is an order in ascending format. So this is how the program works. It keeps on swapping the numbers by checking the number of passes. What we are doing in the program, we are just ordering the data in ascending order. Next, we'll check out the code, how the code works. This is the first line of your code. As you all know, do concentrate. What happens in the first line? What does this area tell? It is basically an assembly directive which basically instruct the assembler to assemble some new code or data. Sort, this is basically your file name or the program name you are specifying as sorting. What does this code tells? It is basically a machine instruction which basically tells what type of program you are using. It is a read only or write only program. Then I will make an entry of the program which basically tells the execution of this program starts from this line, that is entry. Then what is the first instruction here? Move R5, 3. Why 3? If suppose I take an example, if I want to swap 4 numbers, if I want to order 4 numbers in an correct order, the pass will be 3 because n minus 1. What is the value of n? It is 4. So the pass will be 3. That is 4 minus 1, 3. How many passes you have to perform? 3 number of passes should be performed. In the previous example, as we took 8 numbers, so what was the passes? We should give 7 number of passes should be done there. Then I will use a command called next pass load register R0, A. I will first show you how the register A comes. Next pass, this was the first pass. How to start up with the first pass is I should load the address of A into the register R0. That is what consists, what is there in A? A basically consists of some address. This address is basically for the first data which you give. This is basically the address for the first number. Now, already R0 consists of the address of A. Basically, A has the address of the first number. So, the first number is stored in R0. Now, I should move R4, R5. This basically tells you are doing comparisons with respect to the data. That is, register R4 as well as R5 is used so that the number of passes, that is 3, the 3 number of comparisons should be done with respect to R4 as well as R5. Next, I should compare with respect to the register. When should I start up this next comparison? First, I should load the register R2 with the data with respect to R0. That is, now R2 consists of R0. That is, the first number is stored in R2. Now, I should save the data. That is, whatever you have in R2 should be stored in R1. What happened here? The value of R5 is basically stored in R4. Now here, similarly, the register R2 consists of the data which is already stored should be stored in R1. The R2 value should be stored in R1. So what is the R2 value here stored? We have the first number. The first number is stored in R1. Now I should add 4 to the address of R0. R0 consists of this address. Similarly, if I add 4, it will go to the next number. Now basically R1 has the first number. Similarly, I will get the second number by going to this particular address. I have already added 4 because, as you all know, 32-bit, I am using 32-bit numbers. So to go to the next number, I should add 4 to each of the addresses and then shift to the next 32-bit number. Now I have already got R1, that is the first value of the number. First number is stored in R1. Then I will store the second number in R2 with respect to R0. Now R0 value is what? The second number's address is stored in R0. That is, it is reading the second number here. I am just loading the register R0's data into R2. Now I'll compare R1 and R2. What is there in R1 and R2? R1 consists of the first number here. R2 consists of the second number with the help of this. I will compare 1 and 2. That is, I'll be comparing first number with the second number. Then I should do some exchange, right? As I told, swapping should be done. When this swapping should be done? This swapping should be done if the first number is lesser than second, then you should not exchange, or else you should start swapping here. Okay, then if that particular condition is not met, you should directly store the string R0 into R1 by reducing the value with respect to -4, and then you should store the register with respect to R2, which consists of value R0. Then I will decrement the number of passes so that I can take the next comparisons, and then I will check if that particular number is not equal to. If not equal to, you should start branching with respect to next compare. Where I have defined next compare, it is here. It will again go to this and take the numbers and start comparing. So finally, where the resultant should be stored, as we are just comparing, it should directly give you the data which is already sorted. What should be the output of the program? The output of the program should be the sorted array of list. So we'll see how the execution works with respect to the program. So I have already loaded a project of the particular data. I'll stop debugging that program. I'll open the project which I have already stored. So this is the program. I have already loaded the 7th program here. We'll check out if I have added the source code. Yeah, I have added the source code. I'll save, I'll build. No errors, there are no warnings. I'll start debugging the program. Yeah, you can see there are registers. Register panel is already existing. So first I'll feed the data, some unsorted data as 80, 50, yeah, so this is the data I have given 1, 2, 3, and 4. So what should be the sorted array? 30, 40, 50, and 80 should be your answer of the program. So we'll see the execution line by line. The first data is being taken and it will be compared with the next one. Now 80 is greater than 50, so it should be swapped. Then it will take, see here, it will be swapped. See, I gave 80 here and 50 here. So it will be swapped. 50 is lower, it will be swapped now. Now again, it will compare with the next number, 80 and 40. It should be swapped, right? Once the comparison is done, You can see 80 and 40 is swapped now. Now again it will compare with the next number, 80 and 30. Now it should be swapped. In the next step, you can see the data is being swapped here. So after this, what you can see, 30 and 80, the data is being swapped. So similarly, at last, what should be the final resultant is, you can see the swapping is happening still. Till you get the final destination, you should keep on swapping. Now you can see. Can you see what is the swapping number? 30, 40, 50 and 80. If you still keep on executing, no, because the numbers are already swapped, it will come out of the program. So this is the output of your program where you are just swapping the numbers. So I gave the numbers in unsorted format. Now you should get the output in sorted format. Now you can see the data is being sorted like 30, 40, 50 and 80. You have already got the sorted data. So this is how the program works of sorting.